Okay. Everybody got a packet? Yeah? Everybody didn't have one? Alright, look on the very first page there. You have like a title page. But then you have this very first problem over here. It mirrors the one that we just watched about the zombies. Notice what's going on. It says, suppose that a wizard gives you a magic penny that doubles in value each day. If the wizard gives you the magic penny on the first day of the month, first question, what will its value be in dollars at the end of the week? Okay, so you've got your paper here. I'm just going to make a chart. Oops. How much, we're going to find out how much that penny is going to be worth at the end of the month. Any guesses before we go on? Any guesses? End of the month. Read.
I bet it's going to be $5 million.
$5 million, okay?
$207.
$207? $5 million one. That is not Price is Right, outbidding each other. $500? Anybody else?
Just 1 month.
Yeah, just 1 month. We're going to go for 31 days. You start out with 1 penny. How much are you going to have at the end of the month? $14. $23. All right, we got everything from a what?
Probably $1.
$1 to $5 million? All right. Okay. All right, let me see if I can get this drawn here. I need one more. It's a magic penny, but it only doubles, so. All right, so let's say here's day 1. 8, 15. So here's the end of the month, here's the beginning of the month. So we start out with 1 penny, correct? 1 cent. 1 penny. Alright? It doubles. How much do we have? 2 cents. It doubles. How much do we have? 4 cents. Doubles, how much do we have? 8. 16 cents. Boy, we're rich. 32 cents. 64 cents. So I believe A, whoops, 64 cents. A says, how much are you going to have at the end of the week? On the 7th day, you're going to have a whole 64 cents, right? At the end of the week, a whole 64 cents. Anybody want to adjust their estimates?
Yeah.
$60? $16?
It's either $5 million or 2.64.
Okay, so he's halved his, 5 or 2.5. All right, Christian, what do you think? $5?
Maybe 200.
Maybe 200? $12? 8? Okay. All right, 64 cents doubled. You got your calculators, right? 64 cents times 2. $1.28. Ooh, we hit $1.
Wait, I want to change my back to 20.
Next one, $2.56. Next one, $5.24 or $5.12, isn't it? $5.12. $10.24. $20.48. $40. $96. $81.92. Anybody want to adjust?
Yeah.
What do you want to say?
1,082.
1,082, okay? How much? $800. Reed, you sticking with 2.5 or 5? All right. $85. $2,000. Shelby?
903.
903. All right. So, second question says, what will its value be at the end of the second week? $81.92. All right. So, $81.92. What's the next one? $163.84. $163 now. Next one. $327.68. We're at $327. Next one. What is it? $655. $655.36. Oh, you got till the end of the week. You can't change yours yet. We're at $600.
13.
Next one, 1310.72. Oh. Next one, 2621.44. Whoops, 2621.44. $2,621.44. 5,200. I can't see. 5,242, isn't it? Yeah, all right. 5,242.88, and by the end of the third week, 10,485.76. The end of the third week, we're at $10,000. Johnny?
I think it's gonna be somewhere in the 100,000.
100,000's all right.
Could be close to
800,000?
$12 million.
What'd you say?
200,800.
Okay.
11,000.
It's gonna be like,
11,000, all right. Reed, you stick with yours?
I think it's like $1 million or
What do
two.
you think, Kristen?
300.
Oh. 300?
300,000. You got the number.
It's $1 million or two.
$1 million or two, okay. $1 million or two, like there's a big difference between $1 million or two. Come on
If you're
now.
Donald Trump, there ain't.
Well, no, you're true. True, very true. Okay, so next week, $20,971.52.
Wait, what?
Woo, $20,971.52.
$41,943.04.
How much my bank?
All right, $41,943.04.
$83,886.08.
$83,886.08, and then we get to $100. Oh, wait a minute. I think.
$167,717.
Yep.
It's 16 cents.
$167,772.16.
Where do we get this?
$335,544.32, and then we got $671,088.64. And at the end of the fourth week, we have, if I can read my writing, $1,342,179.28, I think is what mine says.
Can I change that again?
All right, we got 3 more days. 3 more days.
I done got it, so
Okay,
can I change
What do you think? Whoa.
2,800,020.
Okay, Christian?
1
$1 billion. All right.
I got it.
$650 million.
$650 million. Wow, Shelby's went from $23 to $650 million.
It's going to be in the
Don't say
trillions. It's going to be
anything.
in the trillions.
All right, so now day 29, $2,684,354.56.
We got one more day. I just
So
lost
we're
one.
at 2 million. Got 2 more days left. Next. You are. You were sticking with it. You were diehard. All right. Next to last day, 5,368,709.12. And on the last day of the month, when we started out with a penny, we now have $10,737,418.24.
Hey, can we buy this at Walgreens?
Yeah, now wouldn't we all like to have that magic penny? All right, now, how many, honestly, if I'd said at the very beginning of this, I'm going to give you the choice. Choice A, I'm going to give you a penny and I'm going to double it every day for 31 days. Or I'm going to give you $1,000 right now. How many of you honestly would have taken that $1,000? I should have asked this at the very beginning. what if I'd said I'm gonna give you $1 million at the end of the month? Nobody would have taken $1 million.
Well, I've heard the joke before.
Yeah.
But I mean, I probably would.
$1 million.
Probably gonna take that.
See, because
Alright.
you don't really think about how much it doubles.
A penny, you think, how many of y'all throw pennies down and never pick them up?
Well, it doesn't double.
Yeah. But,
Well, Dad.
pennies that, they make
collects
dollars.
pennies, like he- like-
Alright, now, here's my thing. Do not go to Florida Blog, don't go to any math people and say, hey, when she asked you this, okay?
What
Put your
about if
chair
we
down.
say, hey, when she asks you this, go for the $1,000?
No, don't say anything. Don't say anything to them. We'll see how good. I should have asked y'all before we started this. Alright, but this is just like the zombie apocalypse, right? You start out with 1 people, that infects 2 people, infects 4 people, 8 people, 16 people, so on and so forth. Assuming that doubles every day. I mean, sometimes it may, if you watch Walking Dead, it may, triple more than that. But the way the virus spreads on there, it's like a flu-like virus. Like but once you get it, and you don't have it, nothing's wrong with you until you die.
Until you die.
And then once you die, once you've been killed, like, you might, whatever, if you die because you had cancer, or you die because you were stabbed in the heart, or whatever, you'll come back. The only way you can kill a zombie is to,
Catch it in the brain.
in the brain, the old brain stem. Okay, so, turn over to the next page then. Turn on over to the next page. So we're actually going to get into the parts where they're talking about y equals ab to the x, and your, whoops, why's my pen acting up? Alright, you're talking about this y equals ab to the x. Anybody remember, or could you tell me what a stands for? Oh, come on. They told you in the video. A is your starting point. A is your starting point. Remember, he started with 1 person, and where did that graph cross the y-axis? 0, 1. Remember, patient 0, 1 person. He infects 1 person. Patient 0. All right, B is your rate of growth or decay, depending on what we're talking about. We're talking about the growth of the zombies, the growth of the penny, versus the decay of the human population, or decay of radioactive isotopes, uranium, something like that. If you get into talking about those things, if you're in, I don't know if you're talking about it in Earth, you probably will talk about it in Earth science. Physical, you should talk about it, how things grow or decay. You're talking about carbon-14. Has anybody ever said anything about that in your science classes? That's how they date fossils, how they found out how long dinosaurs were alive or how long ago they were. All right. I want to keep taking these off. All right, so on that first side where it says 10-5 skills practice, it says graph each function, state the y-intercept, then use the graph to determine the approximate value of the given expression. Use a calculator to confirm the value. So on your calculator, let's go in and let's just clear everything out. You really don't, I don't need the 0 in there right now. So we're going to graph y equals 2 to the x, which we saw what that was already. Y equals 2 to the x. And I'm just going to go to a standard window just to show everybody what it looks like. Alright, so there's y equals 2 to the x. Now, on your paper, go ahead and graph it. So you've got y equals 2 to the x. Y equals 2 to the x. We know that, remember, what did he say? A, when A has to be greater than, not 1, 0. A has to be greater than 0, because you can't start with a negative zombie. Can't start with a negative amount of money. So A is greater than 0. B, when B is greater than 1, it's a growth. And when B is a fraction, it can't equal 0. When B is, and it, whoops, I should have put that, and it can't equal 1, it's a decay. Okay? Don't automatically assume if B is negative that it's a decay. Don't get in, don't fall for that. When B is a fraction. because you're dividing by something. So A is always greater than 0 because you got to start with something positive. B, when B is greater than 1, it's something growing. When B is should put 1 right there. When B is between 0 and 1, it's a decay. All right, so back on that graph, y equals 2 to the x. What's the y-intercept? It's where x is 0, correct? Okay. Where can we find that on our table? Where x is 0. Whoops. Oh, notice I went to my table. See these huge, huge numbers? That means 1.4 with 10 zeros after it. These are really big numbers, scientific notation, which we already knew that because right there's 31, right? Go back up. There, looks like some numbers you're used to seeing. All right, so the y-intercept, where x is 0. So what's the y-intercept? 0, 1, but we kind of knew that. All right, so then the second part says use the graph to determine the approximate value of the given expression. So it says, all right, what is y to the 2 to the 2.3? So we're calculating. They're asking for a specific value. What do you do with your calculator? Find a specific value. Do what, Aaliyah? Second calc. Value, number 1. So we want to know at 2.3. So there it is. We'll just say 4.9. We'll just go to 1 decimal. So it's 4.9. All right, so in there, y equals 2x. What's A in this? Let me rewrite this down here. What's A in this formula? And it's not 2. What is the number that's being multiplied right here? It's not 0, because 0 times anything is 0. It's a 1. There's a 1 right here. Okay, you don't write 1 times 2 to the x. Because 1 times anything is just 1. So that's why it's just written as y equals 2 to the x. So in this formula, A is 1. Why did I write B? A is 1 and B is what? 2. So that's how we know it's a growth, because B is greater than 1. All right, so the next one, before we ever graph it, y equals 1/3 x. Just by looking at this, I know the y-intercept. What's A? 1. The y-intercept is 1. Is it a growth or a decay? What does that say? When B is between 0 and 1, it is a decay. So what is B? B is 1/3. So it is a decay. So before we ever graph this, we know this goes through the point 0, 1, because A is 1. We know this is a decay. So we know it's going to look something like that. All right, so let's type that one in our calculator. So back to the y equals. Remember, fractions require parentheses in this calculator. So y equals 1/3 to the x. I'm going to leave it on that standard graph just to see that standard window that it is a decay. We knew it went through 0, 1 because A was 1. We knew it was a decay because B was between 0 and 1. B was a fraction. All right, this time it says, all right, what's negative 1.6? So just like Aaliyah said, second calc number 1, type in negative 1.6. And what do you get? 5.8? So 5.8. Excuse me. All right, questions on those? Knowing what A is, knowing what B is. All right, now the next two say graph each function and state the y-intercept. So before we ever graph it, you should be able to tell me what the y-intercept is. So on these we have y equals 3 times 2 to the x and y equals 3 to the x plus 2. So what is A in that top equation? What is A? 3. It's written right in front of you. 3. Right here's A. So A is 3. So we know that graph is going to cross the y-axis at where? 0, 3. We know it's going to cross at 0, 3. So go ahead and put your point on your graph at 0, 3. Now, is this a growth or is it a decay? It's a growth because it's doubling. So you could honestly sketch if you I mean, not on this paper, but you could sketch, you know it goes through 0, 3. You know it's a growth, so you could sketch a growth on there. Doesn't have to be perfect, but you could sketch one. But if we went back to our equations and did y equals 3 parentheses 2 to the x power. Whoops, that's not what I meant to do. Ah. There we go. 3, 2 to the x. Still on that standard window. That's what it looks like. The important things to know about these graphs are the y-intercepts and whether it's a growth or a decay. Those are the two main parts of the graph.
So we don't have to find the value for it.
Not for this one, they didn't ask you for a value. All right, number 4. That's one a little different. 3 to the x plus 2. Y equals 3 to the x plus 2. What's that y-intercept?
-2.
Let's be multiplied right here. 1. What do you think that plus 2 is going to do to it? Any ideas? Move up. Anybody else?
I think it's gonna
Move over to the right.
Move over to the right. Okay. So let's go and try it out then. So 3 to the x power plus 2. I've heard move up, move over, move right.
It
It goes over.
Oh, but it's not on the egg.
It has to go through 0, 3, doesn't it?
Yeah.
But look at this. Where did all those other ones go through? Hello? Okay, I'll send her right up. Bye-bye. Kale, you're leaving. Notice when let me go back and type in, if I just do 3 to the x. That one will, so there's the plus 2. Notice the red one? It did move it up, but this red line, it looks like it touches the x-axis, doesn't it? It really doesn't. If you notice on this table, look at the red values. Right here's our 0, 1. Now notice what happens to those red values. They get smaller and smaller and smaller and smaller. That means 4.6, put 3 zeros back that way. 1.7, put 4 zeros. Just get up with somebody. It depends on how far we get, okay? Put 5 zeros back that way. So it gets smaller and smaller and smaller, but it will never reach 0. Okay? It just keeps getting smaller and smaller. So on the graph, that plus 2, it still went through that same place, still went through that y-intercept, but it moved it up to where it's not actually going on that x-axis. All right, so let's see. All right, now, what do we notice, or what have we noticed about growths and decays as far as, we really haven't looked at tables. But let's see, let me go back to this table again. All right, so on this table, what are the x's going up by? The x's are going up by 1s or going down by 1s, right? So they're going up the same amount. Going up by 1s or going down by 1s. What happens to this graph? It goes up really fast, doesn't it?
Yeah.
Okay. What happens to this graph?
It goes down.
It goes down really fast, correct? Or depending on how you want to look at it. All right, so if we're looking at this graph, we have looked at, let me go back to this table. On for 5, 6, 7, and 8, 2 things. When they ask you, it says determine whether the data in each table display exponential behavior, explain why or why not. 2 things. Number 1 has to do with a domain. And you need to write this down and make sure it's in your notes. Your domain, remember, what's the domain deal with? What's the domain deal with? You just did this on your test before, quadratics. You had to tell me what the domain, what the range were. What is the domain? Well, but what were we dealing with, x's or y's? X's. The domains are the x values. So the domains are the x values. And for an exponential, growth or decay, the domain must increase at regular intervals. Means you need to go up by ones, or go up by threes, or go up by fives. So on all of those, why are you not writing this down in your notes? On all of those, like on number 5, they're increasing by how much? How much do I go from -3 to -2? -2 to -1. I'm increasing by 1, right? Okay, so that one's okay. And the second checkpoint for a range, now this time, is the y values, correct? It is the y values. But, just let me write y values down here. For it to be a growth or decay, it has to either go up really fast or go down really fast, right? What mathematical operation makes it increase really fast or decrease really fast? You got 4 operations. Add, subtract, multiply, divide. Multiply makes it go up really fast, right? Divide makes it go down really fast. But if I divide by a fraction, or multiply by a fraction, that also makes it go down. So your range are your y values, and they must increase or decrease, it doesn't matter, depending on what it is, increase or decrease by a common factor. And I'll tell you what I mean by that. Okay, so they must increase or decrease by a common factor. This is something you need to have in your notes. All right, so on number 5, I've already said that the x's go up by the same amount. Okay, so number 5, the x's go up by the same amount. Are the y's, first of all, just glancing at them, are they going up a whole lot?
No.
Not really from 9 to 18, are they? What's happening? What pattern's going on here? From 9 to 12, 12 to 15, 15 to 18. We're adding 3, aren't we? We're adding 3. All right, is that increasing a whole lot really quick? No. We're not multiplying by anything, are we? So when I said a common factor, if you're not multiplying, then this is not an exponential. Okay? This is not an exponential. So you would put no. The domain increases by 1, which is okay. However, or but the range increases by adding 3 each time. So it's not a common factor. It's a common difference of 3. 12 minus 9, 15 minus 12, it's however you want to say that. But when you're answering these types of questions, you got 3 parts, yes or no. Tell me what's going on with the domain. Tell me what's going on with the range. So number 6. Okay, so number 6, are the are the domain values going up by a certain amount each time? Yes, okay, so I know, I'm not going to put yes or no yet, but I'm going to put the domain is increasing or increases by how much? 5, okay. So that's the first part. Domain's increasing by 5. What is the range doing?
Divided by 2.
What? Dividing by 2, right? Dividing by 2, you're not going to say dividing by 2, you're going to say multiplying by what? 0.5, which is 1/2. Dividing by 2, this is something you need to understand. Dividing by 2 is the same as multiplying by 1/2. Okay, so the range, decreases by a factor of 1/2. So the important parts that I need to see in an answer, domain is increasing by 5, the range is a factor of 1/2. So is this a yes or a no?
Yes.
Yes, it's a yes. Alright, so try 7 and 8 real quick. Work with those at your table, try 7 and 8, see what you get. Should be open. 4, 8, 12. Hey,
Yeah, feel that.
where you going?
I don't know. I'm starving, but I don't know.
I'll take anything.
You're going straight.
Probably. Shouldn't take you but just a minute to look at these. Get some idea. Check with your table mates. Got some idea? Anybody? Taylor, what do you think on 7?
The domain increases by 4 and the range increases by 20.
Yeah. Okay, so Taylor says yes, domain increases by 4. Domain increases by 4. And the range, what'd you say?
Increases by 20.
Increases by a common factor of, are you adding or what are you doing? Okay, so if you're adding, then it's not a yes.
Oh, then no. It's increasing by a factor of 2.
It's a factor of 2.
Oh.
Everybody see what Taylor said? Well, it's actually not increasing by a factor of 20 though. Because you're not adding 20 to 40 or to that one. Okay, so Hannah, finish it out for us. The range
Is increasing by a factor of 2.
increasing by a factor of 2. There we go. Alright, so 7 would be a yes. And if you don't have all 3 of those parts, then it will be counted wrong. You gotta have yes and no. What's going on with the domain? What's going on with the range? Alright, everybody want to try number 8? Hasn't tried one. Noah, what did you get?
No.
Why?
They both subtracting by 20.
Well, it doesn't matter, the values go down by 20 on the x's, which is okay, the domain, but what makes it a no?
It's not multiplying and dividing.
It's not, well, what's not multiplying?
The domain and range.
Not the domain, doesn't matter about the domain, it's the range. So you would put no, the domain increases I can't write today, increases by 20, or not increases, decreases, sorry. That should be decreases. So the domain's going down by the same amount, that part's okay. The domain decreases by 20, which is fine, but the range is decreases by 20, which is subtracting, not multiplying or dividing. All right, we're going to skip the other side of that page where it says page 59, and I think on the back of the next page, not the back of that page, but the next page where it says exponentials day 2, is that what y'all have? Yeah. Okay, that's where I need to get to. All right, exponentials day 2, compound interest and decay. So they've got, it says recall y equals ab to the x. These are the actual problems that you're going to get like on an EOC. That's the one that we talked about in the zombie problem. Y equals ab to the x. There's another one, a more common one, and he did mention this. You got a, well, he used p, I think, p for the principal. You've got a equals p times 1 plus r raised to the t power, or a equals p times 1 minus r to the t power. Now, every one of these letters means something. So a, no matter what, a is the final amount, your ending amount. It's the y value. A is your final amount. You need to be putting these in your notes. A is the final amount. These are easy questions you're going to have on your test. And if you are not writing this down right now, then that's your own fault when you fail. A is the final amount. P is they're going to say either the principal or the initial amount, where you're starting. Just like the A over here. It's the starting point. So the little a or the big P. This time R is the rate of growth or decay, depending on what it is. It could be a decay where they're going to say it decays at so much. This is the same thing as the B in the other equation. R is the rate. T is the time. How long does it take for something to happen? And time can be measured in months, years, days. You got to be very careful and read the directions in the problem. You got to have units on these. These are word problems, actual word problems. So you got to be very careful and figure out the time. All right. So in example 1, I'm in this top box up here. Example 1. It says a population of 16,000 ladybugs is released over a forest region. The ladybugs increase in number by 3% each year. How many ladybugs will be present after 5 years? Don't ask me how they know there's 16,000 ladybugs in the forest, but. So I'm going to keep this equation up here. A equals P times 1, and I'm going to put plus or minus R. Everybody understand that plus means growth, minus means decay. That way I don't have to write the same equation twice. Well, it's either going to be 1 plus R and 1 minus R. So they're wanting to know how many is there at the end, right? So they're looking for which variable? They want to know how many is at the end. A. They're looking for A, the final amount. So we're going to say, this is example 1. So A equals, how many did they start with? 16,000, right there in the problem, 16,000. All right, is this a growth or a decay? Growth, so it's 1 plus. Now, here's the one trick. R, how much does it grow by? 3%. You do not put 3 in here. You must make it a decimal. How do we go from a percent to a decimal? Divide by 100. So 3%, which is move the decimal 2 places left, is going to be 0.03. And how many years? say 5 years? 5 years, all right. So here we go. Let's put that in our calculator. 16,000 parentheses 1 plus 0.03. I could just put 1.03. I don't have to put the plus. And I'm raising that to the 5th power. 16,000 initial amount times 1 plus 0.03 raised to the 5th power. Now, ladybugs. Does it make sense to count part of a ladybug? No. So, what would you put for this? 18,548. Because you can't have 0.38 of a ladybug. So 18,548. So 18,548 what? Ladybugs. Don't forget the units. In this case, ladybugs are the units. Got it? Alright, now, example 2. A population of 40 mosquitoes in a jar with bleach fumes in it. Ugh. The mosquitoes die off at 3% an hour. How many mosquitoes will be present after 1 day? What are they asking us for? The final amount, right? Alright, so we're looking for A. How many did we start with? 40. Growth or decay? So it's 1 minus. 1 minus what? What am I plugging in here? 0.03. Some of y'all are doing a great job of paying attention. How many? This says days. How many days? 1 day. Alright, so how many mosquitoes are left? You put bleach fumes in that, fumes, in that jar.
38.8.
Why'd I put 0.97 there? What's 1 minus 0.03? 97. Think about it as a grade. If you have 100 points and you get 3 points taken off, what's your grade? 97. So 0.97. 38.8 mosquitoes. Pretty precise, isn't it? 38.8. So I guess maybe there's a mosquito that's starting to die. Maybe he's coughing in the jar now. He's almost dead. He's getting there. So, but how many mosquitoes are still left in there right now? Alive. What did the question say? How many mosquitoes will be present after 1 day?
1.2.
That doesn't mean 38 died. That means there's 38.8 left.
Oh, what? At least there's not.
Yeah.
They didn't ask you how many died. They said how many left. How many mosquitoes will be present after 1 day? 38.8. How many died? 1.2, depending on, this is where you got to be careful. Does the question say round to the nearest whole number, but it really doesn't say anything, does it? So we're going to say, since it didn't say anything, we're going to say 38.8 mosquitoes. Which wouldn't make a whole lot of sense to have 0.8 of a mosquito. But anyway. Alright, example 3, they gave us an equation this time. Probably asking us to identify parts in there. So they said f of x, the value of a car can be calculated with the equation f of x equals 17,700 times 0.85 to the x power, where f of x is the value measured in dollars. So final amount of the value of the car. X is the number of years since the car was purchased. So A, write the equation in the form A equals. So they want the equation written like that. So what did they do here? Where did they get 0.85 from? What do I subtract from 1 to get 0.85? 15. So this is what? F of x equals, does 17,700 change? No, 17,700 times 1 minus 0.15 to the x, which is really t. thought about it this way, A equals 17,700, bless you, 1 minus 0.15 to the T power. That's what they're asking. All right, so A, we wrote it. Explain the meaning of the R value using the units of the problem. If I said explain what 0.15 means, what would you say? The value of the car is, explain the rate. Decaying at, not 0.15, at, make it a percent. 15%. So you would say, and 90% of you are not participating, you're just writing this stuff down and you're not going to get it. These are easy questions and you're not trying. Let's see, how to explain the meaning of the R value. The value of the car decreases, because it's a decay, decreases at 15% each year. That is an excellent EOC question. That is a very easy EOC question. One that you should know. All right, C, explain the meaning of the P value. What's the P value? What does that mean? The car when you did what? When you bought it. So C, the initial value of the car, did they say it was new? They didn't say it was new, so we can't say when it's brand new. The initial value of the car is $17,700. All right, D, in your calculator, graph the equation. We're not going to worry about that one. How much will the car be worth in 3 years, 12 years, 25 years, 100 years? We're going to do that one very quickly. So let's put this equation in our calculator. So it starts out, oops, let me take that one out. All right, so it starts out at 17,700, maybe. And then it was 0.85 raised to the x power. So 17,700. We don't really care about the graph. We just want to know certain what? Certain values. So if I'm going to hit graph, and it may not show me anything because my window probably is not on that, is it? My window goes from -10 to 10. Where does that car start at? 17,700. Well, if that goes from 0 to 10, it's sure not going to show me 17,700, is it? So let's go to our window and change that. Let's make this one 0, and let's just say 20,000 for Y max. And what do we want to count by? Thousands, maybe? And look at what they're asking us for. The value in 3 years, 12 years, 25 years, or 100 years. Where our X only goes up to 10. So we got to change that one too. So let's just make that one 100. Or let's make it 120, I guess. I don't know. I'll count by 1. So we're just trying to see the graph. So it's not that big of a deal. So there's our graph. So that car, what happens to a car?
Loses value.
What happens to the value of that car really quickly? It drops, and then what happens? Then it kind of levels off. So, all right, listen very carefully. You're going to finish that one, and then you're going to do the next 2 for homework. Everybody got that? Finish that problem and the next 2. It's actually 3 problems. You'll have 4 total for the homework.